Hello! As part of the Advanced Control Tour, we received a work to do on the BALBOA robot in Paris. We chose theme number 6, which was one of the themes proposed by our teacher. Then here are the different points that this video will contain. We will explain in a way to summarize our project. Objective number 1 is to implement one or more of the algorithms that we introduce in the Advanced Control 1 courses on the BALBOA robot. As said just before, we have chosen subject number 6, which is called Slam Robot. The goal is to able to build a map of an unknown environment thanks to the robot. This will also be remote controlled with our laptop.
These are the main objectives we try to meet with the project. We want to make a laser sensor with a servo motor. The data that is collected should be sent to the PC with MQTT. A laptop will control the robot using users' inputs. The BALBOA will compute basic odometry, and the odometry will also be sent to a laptop. And finally, we want to use the data with a SLAM algorithm. Before we start to do anything, we need to install the Raspberry Pi operating system. We also need to enable SSH so that we can use VNC to control the Raspberry Pi. Then we will install Hotspot Tools v2 to be able to access the Raspberry Pi even without Wi-Fi. Finally, we need to install MQTT and the other dependencies like the Python serial package or NumPy. This will enable us to use the Raspberry Pi with our BALBOA robot.
In this section, we will talk about the communication between the BALBOA and the Raspberry Pi without going into too much detail. Here, we will communicate in series thanks to a USB cable connecting the BALBOA robot to one of the USB ports of the Raspberry Pi. The principle of serial communication is to sequentially send one byte of data at a time from one location to another. This way of communicating uses strict protocols ensuring the security and reliability of communication. UART stands for Universal Asynchronous Receiver Transmitter. It is a hardware device present inside the microcontroller used for serial data exchange between two devices. The pin called TX is used to transmit data and the other pin called RX is used to receive data. We can only connect two UART devices together.
To send information between the laptop and the Raspberry, we use MQTT. We are using three topics. The setpoint topic is used to send commands from the laptop to the Raspberry Pi. The commands are then sent to the BALBOA via serial communication. This will allow us to control the robot from the laptop. The scan and ADOM topics are published by the Raspberry Pi. The data is then sent to the laptop under JSON format, and we can then retrieve this data to display the map on the laptop. To use MQTT, we also need a MQTT broker that is running somewhere. For our project, the MQTT broker is running directly on the Raspberry Pi and is starting at boot up of the Raspberry. The laptop, which is connected on the same Wi-Fi as the Raspberry, will then be able to access this broker as well as obviously the code running on the Raspberry Pi.
We will talk now or later show the wiring diagram we made on the BALBOA robot. As said before, the BALBOA is connected to the Raspberry Pi by a black USB cable here to be able to communicate. Then we can see in the middle the buck converter connect to the ground and VSW pin to reduce the voltage because the Raspberry Pi must be supplied with 5 volts, while the BALBOA provides a battery voltage higher than 5 volts. Finally, we also see the assembly of our thermometer and the true sensor on the right.
Software, we have three different parts. The first part is written in C++ and runs on the BALBOA. This code will control the BALBOA as well as compute the odometry that we need for the scans. The second part of the code is the Python code running on the Raspberry Pi. The code will control everything related to the scanning of the data. It will also be used as middleman for the control commands coming from the laptop. The last part of the code is running on a laptop. This code will receive the scanning data as well as the odometry, and it will display a map on the screen. It will also send the commands to the Raspberry Pi that we get from the keyboard from a user. We can now look at a video of the robot running in a little room and look at the map it will create.
The first idea to improve this project is to replace the scanner with a scanner with a much higher sampling rate. This will reduce the number of serial communication and allow for better control of the robot. A second idea to improve the robot is to use the magnetometer as a reference point for the BALBOA heading in the odometry. The third idea is use ROS on the Raspberry Pi.
Regarding the initial objectives, we have succeeded to meet 4 out of the 5 objectives. The last objective is mainly held back because of the slow sensors we have. As discussed before, by changing this sensor, the robot would be greatly improved. Thank you for looking at our video. If you want to know more about the project, you can go to our GitHub project page.